Hello, everyone. Welcome back to the AAS YouTube channel. And this is part of the good stuff. This is part of the great stuff. And I am delighted to have Abril Sahade with us today. Hello, Abril.
Hi Frank, how are you doing?
I am doing awesome on this August 6th, 2025, as we record this. And let's see. Abril, what is your geolocation? Where are you at?
So I am at DC, Washington, in the US.
Very good. Okay. It looks like we got a little overcast today.
Yeah, we have some clouds, it's great. Last week was like kind of hot, so we are having nice weather.
Ooh, but the humidity's up a little bit. I mean, it's East Coast, so
Yeah, here
going to
is
get the humidity out. Yeah.
yeah, that's a
Um,
problem.
yeah. So I'm in Phoenix, and while the humidity is much less on the East Coast, the temperature is way up there. So we will
Mm.
probably hit 44 C today, about 115, 116 today. So we are going to rock today. So yeah.
I'm sorry for you.
Oh, it's okay. It's okay. What you learn to do is you learn to get up really early in the morning and you do whatever you have to do at crack of dawn before things get a little uncomfortable. So
And then hiding Daisy, yeah, okay.
yeah, and then you take a siesta in the afternoon, basically. It's great. It's wonderful. All righty. Let's see. And Abril, what do you like to do for research?
So I really like CMEs, coronal mass ejections. I like all this evolution and interaction with the magnetic fields, onset, all the
Cool.
way through the corona, and then what happened when it goes to in situ. That's
Yes.
the last part, right? Like, so I like all the way of CMEs.
Very cool. Very cool. And that is going to bring us to this very awesome APJ letter. It is open access. It's the open access air, people. You can go grab a copy for free. Go get one.
Yeah.
Observations of a new form of partial filament eruptions. And Abril, take us away.
Okay, so this paper, I did it with Judy Carpen and Spiro Theokos. The three of us were working at NASA Goddard Space Flight Center, sorry.
Mhm.
So, okay, yeah, Judy in particular, she's my MPP NASA postdoctoral program mentor, and Spiro is a collaborator of the team.
Awesome.
So we had a lot of discussion about this event. We wanted to bring it to the community so everyone can check on them and try to understand what is going on here.
Awesome. Very cool. Great shout out. Great shout out. Okay, let's go.
Okay, so here the thing is like, okay, we do know that coronal mass ejections are these eruption events
Mhm.
where we have, before this onset of the CME, stress magnetic systems, and this stress magnetic system can lead to flares, energetic particles, and all the way to the impact in the Earth, right?
Yes.
And one of the main goals here, or well, in my research, is to understand whether or not a flux drop or shear arcade will erupt or not. So if it's gonna depart from the sun or stay there.
Right.
So in that sense, we know that these eruptions come from filament channels, and these filament channels can erupt full of them, like have everything going out, or we can have things being confined, or we can have a mixed situation where some part of it erupts and other part doesn't erupt, right?
Okay. Hmm.
And well, first things first is like we know that this stress system is going from shear case to magnetic flux ropes.
Okay.
That's like some sorry, it's you go from one to the other one, and where that moment when the shear case becomes into a flux rope is still a question.
Okay.
That can give us some hint about how much of this system will erupt and how much won't. And then like even we have the situation, which are the conditions of the environment also matters in terms of when they will erupt or not.
Okay. I'm with you.
Okay,
I'm with you. Yep.
okay, good. Sorry, I am a bit nervous, so I am going
All good.
for back
Relax.
and forward. But okay,
You're doing great.
so.
I'm following.
Yeah.
Doing good.
That's good.
Okay.
Thank you. Okay, then
Mm-hmm.
when we talk about observations in particular, we have these signatures like filaments, which
Mm-hmm.
are these cold plasma material staying there in the low corona, and we know that that is related to the magnetic field,
Mm-hmm.
and it's supposed to be in the bottom of these stress magnetic systems.
Uh-huh.
Okay, the thing is like in the observations, we cannot see the coronal magnetic field, but we have these hints. So these filaments are sometimes partially erupting.
Ooh.
That means that part of that cold material will go out and part of that material will stay in low corona.
Okay.
And in that sense, we have typically like two different types. One is like the horizontal splitting, which means that from the whole filament channel, some part of this cold material will remain here and the other part will erupt.
Yes.
That can be like due to external reconnection. So the reconnection with the environment allow one part to erupt and the other part will still be here.
Okay.
And there are other kind, I think it's in the other side of the
Uh-huh.
page,
Yeah.
where we have the vertical splitting. And
Ooh.
that vertical splitting means that the same portion of the polarity inversion line where the filament is laying above
Okay.
it will erupt. So like this filament will be split in this way.
Yes. I'm with you.
And there are
Okay.
different options in the theory to produce that kind of splitting. One is like having two different magnetic systems and having like what is called like double-decker magnetic flux rope. So like you will have two separate kind of flux ropes. One will erupt and the other one will be there, will
Okay.
stay there.
Cool.
So okay, in one sense, then we have these partial eruptions being important for the whether or not a
Yes.
CME will occur. And in the other hand, we have events where we have this splitting and we produce what we call a full CME, which means like we have this magnetic flux rope, like bubble kind of erupting, or we can have jets. Jets are like the same initiation process, the same magnetic nature,
Yeah.
but when they reconnect with the magnetic environment, then we won't have like this perfect flux rope, we will have like more open fields.
Right. Okay. That's
So,
presumably through the null point. Uh-huh.
okay,
Okay.
yeah, is
Yeah.
this kind of reconnection with null points would give
Yep.
us like the opening of the field.
Yes, I'm with
So
you.
again, all these like continuum spectra from jets to CMEs or magnetic flux of CMEs will depend on the amount of energy, on the how is the magnetic field, trapping magnetic field. So if it's
Yes.
closed, if it's open, if we have null points. There are many good studies about this. Here you can see like Wiper, Mason.
Yep.
I don't know if I am pronouncing these terms correctly. I hope so. um,
Close enough.
Chang, so yeah, there are many nice studies. I recommend them.
Uh-huh.
So the thing is like, and Kumar also, yeah, they work a lot on that. So the thing is, we have this whole set of how eruptions can be. They
Uh-huh.
are connected. And here, what we are presenting in these three observations, three examples, are cases where we have this splitting of our filament after the activation
Oh.
of the filament. So the
Oh.
filament starts to erupt, then it breaks into splittings too,
Mm. Huh.
and that splitting has been observed before.
Mm-hmm.
But when you have that kind of splitting, you are expecting your magnetic system to be disrupted, and
Yes.
in that disruption, what will erupt should be, or we are expecting to be like more a jet characteristic, right? Because for
Yes.
a CME, we need like this more flux or more structured thing evolving out.
Yes.
So the question here is like, what is happening here? What is going on? And the
Mm.
thing about these three events is that the three of them are embedded in this pseudo streamer topology. Yeah.
Okay. Okay.
What is a pseudo-streamer?
Yes.
Pseudo-streamer
Good
is
question. What is a pseudo streamer?
what is a pseudo? Okay, so well, the magnetic field of the sun is very complex. We have many different kind of topologies, but we like to name them somehow. So pseudo-streamers are these places where we have embed polarity regions. So we have open field of one polarity, but then in the middle we will have a different polarity, and that will give us some closed field lines
Yes.
below and the pseudo streamer above it that will give us a null point and above the region that we are interested in,
Okay. Okay.
and a lot of open field around.
Cool. Cool. Okay. Awesome. I'm with you. Hmm.
Okay, so this particularly is also the scenario of the breakout model from Antiochos. Um, and well, many papers had, many authors, many people had talked about this, and this is one of the mechanisms for eruptions to occur. Okay, so the thing is like, okay, this is the common characteristics of these three events, and it's difficult to understand from the models that we already have how we can have this filament activation and then the splitting of the filament, and later on a CME and not a jet.
Right. Okay.
So here we are presenting these three events that we found. The nice part of them is that they are observed simultaneously by three extreme ultraviolet instruments, which are
Yes.
like SDO,
Mm-hmm.
AIA,
Mm-hmm.
Stereo A, UV, and Solar Orbiter EY.
SDO. Yes. Okay.
Okay, so by being observed from three different points of view, we can like really see where they are, track them, and have like correlation spatial and temporal of all the parts of this eruption.
Very nice. Beautiful. Beautiful. Okay.
Okay, so again, we think that these are like, and we call this like a new form of partial filament eruption
Mm-hmm.
because it, the different thing about other partial eruptions is that the filament is activated before the splitting, right?
Yeah.
And after that activation, we have a successful part, a CME, and a confined part of the filament.
Okay. Mm-hmm.
Um, and of course, okay, so the group in which I am working with, or people which I am working with, we are more about like people from the modeling part, Judy Carpenter and Spirit Antiochos, and we haven't seen simulations where these have occurred, right? Like
Mm-hmm.
not in the models that we run, but in not in other models.
Okay.
So
Mysteries.
uh,
Mysteries are good.
yeah. So again, here we are presenting these events for the community. We are trying to understand them, and we would love the community to pay attention on them and try to explain them with us.
There you go, people. Go for it. Theorists, do your thing.
Yeah. So, okay, first thing first is like what we try to do here is to prove that these filaments and this splitting are like real. So they are coming from the same magnetic system, right?
Yes.
And to do that, since we have these three viewpoints, we could track it. We could track it in time and in evolution. And that's what about like, this is like the observational methodology that I am describing here, we are describing here.
Mm-hmm.
So to do so, I use this tool that is like the CC Measure 3 routine. CC Measure is like in the bottom
Ah,
of that
yes.
paragraph, so sorry.
Mm-hmm. I'm good. I'm with you. Open
So
source. Go get it. It's open source.
yeah,
Get it.
yeah. Everything here is very openly. All the data is also available online, so
Nice.
everyone can check on it.
Mm-hmm. Very good. Cool.
And okay, so here I just adapt this routine that have been developed by Bill Thompson for stereo era.
Uh-huh.
So what I did is like this is a stereoscopic reconstruction. You have two point of view of the same thing,
Mhm.
And with that, you can reconstruct the 3D position. So by having 2 dimensions in 2 images, you will have the third dimension, 3 dimensions.
Yes. Yes. Yes.
So the thing is, like, with 2 images, you can do that, but having a third image helps you to avoid ghost features and to validate your selection. And also it is much less time to do it, because otherwise you have to be very, very careful on your selection.
Or skeptical. So yes.
Yeah.
Yes,
Um,
absolutely. Very good. Very good.
so
Yeah.
yeah,
Yeah.
yeah, this is also, I think that this is a tool, a nice tool. It's available there for whoever wants to use it, whoever that is doing tracking of features.
Hmm.
So yeah. So again, like, having these 3 points of view and having all the coverage, all the evolution of the filament, we track different features of it. And then we know that there are no other eruptions occurring at the same time.
Right.
We know that all the confined and eruptive material are connected between themselves.
Right.
And okay, yeah, so the thing is, like, a solar orbiter has a cadence of 10 minutes, right? But we are using the full cadence of AAA, which is like only 36 seconds for each band,
Okay.
to really
Okay.
keep tracking by eye of the features. So we know that we are tracking the same material image by image,
Right.
time by time. Uh,
Very
and then, so we said, like, okay, the eruptive part produce a CME. So to know where that CME is and to see how it evolves, we use the GCS, the graduate cylindrical shell model, which is a very common model in the
Mhm.
community,
Yep.
to obtain the kinematics of that CME,
Nice.
just in order to understand if it's a very slow CME, if it's a fast CME, and how it's connected to the source region.
Yes. Okay.
And since, okay, things like all these CMEs were embedding these pseudo streamer topologies, so they are interacting with coronal holes. So the 3 of them were very deflected by the coronal hole direction. And then we use this non-radial GCS, which just keeps the food points in the source region, and then had an extra free parameter to tilt the angle of yeah so sorry, of the head of the CM.
Yeah. That's a help.
Okay.
Hmm. Okay. Very
And then
good.
the idea, yeah. So we did that, and we compared that, like, all the position of these eruptive, confined, and later CME positions with the magnetic field reconstruction. We used the PFSS, the potential field subsurface model.
Mhm.
Um, so the bad part about this event is that they were out of the limb, like behind the leaf of AIA. So
Oh,
you
okay.
can observe the evolution of the events, but the magnetic field information is very unupdated.
Yes. Okay. 6 hours.
So, but we check on the full rotation, Carrington rotation, and these features, like the pseudo streamers, were there during the whole rotations. So we are kind of sure that those are there, but we cannot have more information on the small scale of the magnetic field, right? Um, no, we don't have more detail. Here is all the information so people can reproduce also our results.
Cool. Okay. I'm with you. I'm good. Hmm.
Okay, so yeah, that. Um, Again, okay, so yeah, I don't know, maybe we can go to the first figure. So
Sure. Let's get a viz on what this looks like. There.
yeah, we are talking in the air. So okay, this is one of the events. So the white arrow in the first panel is showing this filament when it starts to erupt.
I'm with you.
And then the middle figure, the middle panel, sorry, of the figure is showing the moment of the splitting. So that single filament in the first panel is now splitting into a confined the
Okay.
black arrow, and an eruptive part, the green arrow.
Okay.
And as you
Cool.
can see in that image, like both parts of the filament look very entangled between themselves.
Yes.
And since we do this tracking, we can check like really they are entangled, spatially entangled, right?
Yes.
And then in the third panel, we have a later moment of the evolution where you can see that the black arrow still point the confined one, which is still in the same position than before, and the
Yes. Hmm.
eruptive part, green arrow, which is like showing the eruptive part of the filament.
Yes. Cool. Very
So that material that is flying away is the part that later on will produce the CME as we see it in the coronagraphs.
And the whole thing takes about 50 minutes. Hmm.
Mm-hmm. Yeah. So if you want to show the video now of that picture, so
So an
this is
unusual
like.
thing about this letter, people, it's got quite a few movies and several interaction figures, and we're going to check them out. So let's go to the first movie. There we
Mhm.
go. Figure one. Let's roll this. Bang.
Okay, so here is the full evolution
Ooh.
observed by solar orbiter and then by stereo A. So this is a bit out of limb, so it will come a bit later.
Mm-hmm.
Here it
There we
is.
go. There we go.
So
Yep,
there
saw
you
it.
have it. And then AIA
Oh, nice.
with all the bands of
Yeah.
it. So
Yeah. Mm-hmm.
so the thing is also like
Bang.
um those are the arcs. So with all that information, we could track it, and that's the CME, which is a kind of faint CME, but
Mhm.
it's a decent CME still. It's
Yeah.
not, again, it's not a jet, it's a CME. It has the structure of a CME.
Yes.
Okay, so here, yeah, the idea is to present all the videos, all the information, so people also can see them,
Let's
check
roll
them,
down.
and
Boom.
that's our, yeah.
Then sometimes you have to watch movies twice to get all the nuance.
Yeah, of course. Yeah, I really like to stop it and put it in the cadence that I like it.
Yeah, very good.
Yeah.
Very good. Cool. And what is that?
Yeah, it's kind
Oh,
of
there it is.
more behind the lip, so it takes a
Yeah.
while.
Yeah, you're getting at the angle. Yes. Uh-huh. Nice. Very good. Cool. There's a stereogram. And
And that,
there it went.
that's the CME. Great.
There it went. Very cool. Nice. Beautiful movie. Love it. Okay.
Great. Okay, thank you. Um, so okay, here you will have, yeah, a description of what is going on in the three events, in the three
Right.
movies, like time by time.
Mhm.
So the thing again is like they are towards the limb, like of the three spacecraft. So despite the third event, we don't have many information about what is going on with the food points, which could be a good information to have. You know, I'm sorry, it's the second one, maybe.
Second
Yeah,
one? Oh, okay. Thought you were on the third one. I'm good. Hmm.
yeah. That no. Oh, sorry. Oops.
So the first one was, let's walk this. So the first one is October 28, 2022. The second one is Feb 5, 2020.
Yeah.
And then the third one is later in 23, October. Okay.
Mhm. So, okay, the things like we don't have many good information about the food points, which can give us a hint of how things are reconnecting and if how much is the external reconnection uh, doing the splitting, how much is the flare reconnection doing the splitting. But in any case, we are trying here to present the events and
It's a
look for
discovery.
more than look at as them.
It's a discovery. Very cool.
Okay, so yeah, by doing so here, okay, you have the with this reconstruction that we did of the events. So
Mhm.
then with the three image we match in position like three-dimensionally, which is like the confined part, like the black dash line that
Yes.
correspond to the black dots in the D panel
Got it. I'm with you. Yes. Hmm.
E. And then, okay, the green dash line in the images correspond to the green dots, and then the arcs over them, like that connects both parts are the gray arcs.
Very cool. Okay.
And then we have the open fill lines of the pseudo streamer in which it was embedded.
Got it. Very cool.
So this is to give the people the connection of the things like for one time step, but we did it for the whole evolution.
Right.
But yeah, again, the idea is to show how things are connected.
Very nice. And this whole thing takes on the order of a minute, actually less. Yeah.
Yeah,
10
this is
seconds.
yeah, this is like the 3 points of view in the closest time step.
Okay.
So
Okay. Got it.
yeah.
Got it. Mm-hmm.
So yeah, like yeah,
Okay.
the idea was to reconstruct these features, like try to match what I am seeing in UI and what I am seeing in UV. So match the features and then get the position of them.
Got it. Cool. All right.
Um,
And this one, D, is one of the novelties of this article. There's an interactive figure with that one. And I think we got that one. Let me pull this up real quick. Bang. So, yes, this one.
So, okay, great. So what has this figure is like, since we have the 3D position of these events,
Very cool.
here, this is like the projection, like those 3D structures in
Uh-huh.
the sphere of the sun. And there you have the open field lines, and these meridians correspond to the point of view or the meridians of the spacecraft. So you can scroll, check on how like not only the projection that I am showing to in the D panel, but you also can check, and there you have the real 3D coordinates in solar radii, Cartesian solar radii.
Go to another dot, and there's trace 6. Gotcha. Very good.
Each dot has the coordinates, and
Trace 8.
also yeah,
Cool. Very good. And let's see. Let's get one of those white guys. Use the connection between the two. That's the white dots.
yeah. I think that you can zoom in also.
What do I got to do to that?
Like I don't know if you have a mouse or oh yeah, there you go.
Oh, very good. Okay. Okay. Yeah, now it matches the figure a little bit.
Yeah.
Beautiful. I like this.
So yeah, each of those dots is like a pixel, right? Like it's a reconstruct 3D pixel, so
Mhm.
features the image.
Nice.
And we did so for the whole evolution. So again, what is the idea? The idea is to really know that we are following one filament and that filament is splitting. There are not two filaments. They're not. They are connected spatially,
Yep.
and that spatial connection is also related to the environment in this pseudo streamer field, right? You can see how the black dots kind of remain below the open part of the field, like
Yeah.
in where the pseudo streamer is in the cusp, near the null point.
Uh-huh. Very good. All right. I need the white dots
So
in the background.
yeah,
Huh.
this may give us a hint of what can be happening.
Okay. Good. Good. All right. Very good. Love it.
Okay,
Okay. Back to the article.
okay, okay. So again, what we are observing is this filament activation. Okay, maybe we can go to figure 7.
Figure 7.
Yeah.
Figures 3 and 4 are like 1 and 2, but for the other two events that are in the paper, so they also have some wonderful animations and interactive figures to play with, and we'll let you, the interested reader, check that out.
Yeah, sorry, yeah. So, but
Love
yeah,
it.
these are the other events. Okay, this is the one that have a little bit of on this information.
Mm-hmm.
Yeah.
Okay.
So again, yeah, the idea is the same. We did the same. Um, and okay, so here we are presenting the kinematics of the event,
Okay.
where you can see how is the time height profile evolution.
Mm, good, good.
And
That's cool.
so for it, for example, for the 22 October 28 event, which is the first panel, we have two times where the whole filament is evolving together, and
Yes.
then we have the splitting. So we have the green line going to the eruptive part and the black part continuing in the confined part.
Yes. Very nice.
As you can see that the confined part remains at the same height during the evolution where it is still visible.
Mm-hmm.
And then we have the evolution of the eruptive part
Diamond.
going up.
In diamonds?
Yeah, and the green diamonds are the height of the CME obtained by the GCS.
Yeah, I note the scale break here.
Yeah, the scales break because they were like two different, and so to see to be
Yes,
see
in
the
both you
confined
have to
part.
change scale, but I just wanted to call attention to that.
Yeah, yeah. So yeah, again, like you can see things like which is the height at which each event was split, which is 1.2 solar radii for the first one, 1.4 solar radii for the second one, and about like 1.15 solar radii for the third one.
Got it. Nice.
And the three of them occur after the filament activation. That's again one of the main things.
Mm-hmm. Mm-hmm. Nice.
Yeah, okay, I don't know if I want to say it. Okay, well, but again, like we have this GCS made out of the CMEs that we can observe later on.
Yes.
And that give us a hint of like which is the speed of the CMEs, which is around like depending on which, but from 500 to I think 900 kilometers per second, which is like a moderate fast CME.
Yes. Okay. Nice. Very cool.
Cool. Okay, so and the goal here was trying to describe or understand with the models, right? Like try to
Mm-hmm.
explain in which scenario we can have this kind of splitting.
Mm-hmm.
Um, and to do that, we are now like going from the observations of plasma to the magnetic field, like that sustain that plasma, right? Like which is the configuration or which is the onset mechanisms for these events. So again, like we have in general, we talk about like four different models
Okay.
for onset, which are like down there. We have the kink stability, we have the torrent stability, which are the
Okay.
ideal models. We have feather cutting or flare reconnection, and the breakout model.
Here we go. Bing,
Those,
bing.
yeah.
Okay.
So, okay, the idea was to understand which of them could produce these observations or these phenomenon. Um,
Hmm.
the first that we kind of rule out was the kink stability because the filament doesn't look like twisting.
Right.
So that doesn't seem to be playing an important role here. And about the torn stability, could be a good one in the cases where we have this idea of the double decker. Because if we have two different systems, then maybe they go up together and then one erupts and the other one not.
Okay.
But even in that case, the question is how or why the both of them are first activated and then one is halt and the
Right.
other one is eruptive.
Right. What caused that?
And we don't have any signatures of a double decker. We don't have any signatures about having different parts of a filament. Um, they look all together.
Right.
Everything
Okay.
looks very consistent. Um, then, okay, we go with the reconnection models.
Uh-huh.
So we have the feather cutting, and in this case, if we have this activation of the filament, we will start having reconnection behind it,
Yes.
but that will make it unstable, the full filament, like all the filament channel that is being eruptive will erupt. But the question is like how we can now this system that start erupting have a second round of
Right.
feather cutting in the
Right.
middle of it and get it split in two. And again, why that second splitting will give us an eruptive and a non-eruptive part.
Mm-hmm. You got
Um,
to gyrate around a little bit to get this one to go. Okay. Okay.
And then, okay, so the fourth mechanism is the breakout, and something good for that mechanism is the configuration that we have overlaying that system. That is the pseudo streamer. That means that we have null points, so we have the place to have a breakout reconnection.
Okay.
So the idea here will be like, okay, maybe this breakout reconnection is giving us the instability of the shear case, so the shear case start to evolve. And then with a shear case still, we will have the tether cutting below it and reconnection and the splitting.
Okay.
But still, this is a bit difficult.
Yeah. Okay.
Because we will have the activation of the full shear arcade or all that part of the shear arcade and then the splitting, and why one part of it remains below the null point and not all the system goes away. And something else is that in the simulations of this that we all have that we have in this group is like none of them show that.
Okay. Interesting.
So we like the idea of, or we think that breakout should play an important role. That also is sustained not only by the topology that we have above it, but we see signatures of reconnection because all the emission, because we have emission in the different wavelets.
Right.
So we have signatures of reconnection in the upper part of our filament. And in the event that we have this information, we can also see signatures of external reconnection, like circular ribbons that can give us a hint that our filament or our magnetic system is interacting with the null point. But the question is like whether it's happening before, which is happening after, when it's happening the breakout, when it's happening the tether cutting, how this whole situation led us to this partial eruption.
Right.
So, okay, just wrapping up to the conclusions. These observations are really difficult to understand in terms of our current models.
Right.
Of course, nature is not that simple. Everything may be happening together, but it will be great to understand in which order or in which amount each of them.
Yes. You're gonna make a cocktail here. A little bit of this, a little bit of that. Yeah. We'll call it the partial cocktail or something.
Yeah. And so I think that the main questions are for me at least like whether we can produce simulations where this happens, like activation of the filament, splitting later on, CME afterwards.
Yes.
Then, if we can, how common are these events?
Ooh.
This is a good question.
Yes, it is.
Then, if they are common and we can find more, it would be great to find events that are very good observed or better observed from AAA perspective, which means we will have updated magnetic field information, better cadence of them.
Yes.
To check on these mechanisms or like reconnection mechanisms. And then third, like what can we learn from these events in terms of whether eruptions will occur or not? The important thing for me, or one of the important things about partial eruptions, is that they are under the same magnetic system. We have in principle, coherent magnetic system under the same underlying magnetic field.
Yep.
And then something happened to it, and part of it is erupting and part of it is not. So, which is the difference between these two parts of the system that led us to a confined and successful eruption? So I think that in terms of space weather, these kind of events are very important. They can give us a lot of clues of which are the main condiments or the main things, the important things on eruptions. So okay, I think I did my I gave my points. And again, I think that this is like just first part, or like the idea was to take the attention of the community on these kind of events.
Mhm.
So we would love to see a continuation of other people's trying to find events like this,
Mhm.
trying to understand them with us,
Yes, yes.
with us. And okay, our goal now is trying to simulate these kind of things. And to do that, we need like maybe more flexible configurations.
Hmm. Hmm.
So that's why what we are trying to do now, like trying to add the right condiments to have a splitting of this kind.
Cool. Very cool. Abril, that was awesome. Beautiful. And thank you so much for walking us through your very awesome APJ letter.
Thank you so much. I hope people can read it and enjoy it and find the same questions that I.
Uh-huh. Uh-huh. And you touched on it a little bit there toward the end.
Mhm.
So let me go ahead and push on that a little bit and ask, where do you think we go from here, given the published article? So, for example, right now we have 3 events. What would it take to get 30 events? Is there more observations just sitting waiting to be analyzed, or is there new data coming down the pipeline? Or is there new missions that may be launched, let's say, within inside of a decade that might be able to help inform this? And yes, then you have to do your 3D MHD calculations. Yes. Uh, so just, where do you think we go from here? A little bit more.
Okay, that's a great question. So I think that, of course, new data is great, and if we have like new instruments, we will have more information. That is very important. But there is also a lot of data existing. Analyzing that data and checking to see if we find these kind of events is also a huge effort, and will be think great like more people doing it.
Would there be other wavelengths that might be advantageous for one part or another? Like, maybe I'm just making this up. X-rays in some regimes or the low ultraviolet, that kind of stuff.
Yeah, yeah, of course, all those wavelengths will give us more hints on the reconnection part.
Right.
So those are very important, of course, to rule out or understand which mechanisms are taking place here. Yeah. Also, for example, new missions like Muse that will give us spectroscopy and then like flows, velocities will be great for this kind of studies.
Awesome. Cool. Well, it'll be really exciting, I think, to see this develop over the next couple of years and follow up on this lovely discovery. So very
Finger
cool.
crossed to see how it continues. Yeah.
Very cool. Very cool. All right, Abril, thank you so much.
Okay, Frank, thanks a lot, and it was very nice to chat with you about this paper.
And that will do, everyone. And I hope this made your solar day just a little bit more partially great. And we will see you on the next one. Bye bye.